Hello everyone. In this video, we are going to see how to control a robotic arm in Isaac Sim. For controlling the robotic arm or manipulator, we are going to use the MoveIt tool, which allows us to do motion planning and joint control for any robot easily, and then use that setup in Isaac Sim. So let's start with MoveIt. First, you need to install MoveIt. For that, open the browser and paste the link, which I will mention in the description, and follow the instructions. We need to complete the steps until the Qualcomm build. Once it is installed, you will be able to see the workspace folder for MoveIt. They have already provided some project files for robots that we can use. Here, I am going to use the Panda robotic arm from Franka Robotics. If you are using another robotic arm or a custom robotic arm, the procedure will be the same. So open this folder, then go to src, MoveIt_resources, Panda_description, and then Earth. Here you can find the URDF file for the Panda robotic arm. You just need the URDF file for your robot along with its supporting files, like meshes and STL files, to configure MoveIt and use it in Isaac Sim. If you already know MoveIt configuration, you can skip this part and move to the next part directly, or you can watch this section at 1.5x speed. As we have the URDF of the robot, we will start with the MoveIt configuration. Now open the terminal, source ROS2, then source the MoveIt workspace, and open the MoveIt Setup Assistant with the following command. You will see this GUI. Now click on Create New MoveIt Configuration Package. Here we need to load our robot URDF file. Click on Browse. Go to the directory where your URDF file is located. For me, it is inside the MoveIt workspace under Resources, as I showed earlier. Then click on Open, and now click on Load Files. The robot will load properly. Sometimes it may give a segmentation fault error. If that happens, just close the window and reload the URDF, and it will work. Now you can see our robot loaded on the right-hand side. Next, we need to follow these steps to configure the robot. Click on Self Collisions, and then click on Generate Collision Matrix. This will generate the collision checking rules between different links of the robot. Next, click on Virtual Joints. Here we need to add a virtual joint, which is used to connect the robot to the world frame. Click on Add Virtual Joint, give the name Panda_virtual_joint, select the base link as Panda_link0, set the parent frame name as Panda_world because it will be connected to the world frame, set the joint type to fixed, and click Save. Now the virtual joint is created. Next, click on Planning Groups. Here we need to define separate groups for the arm and the gripper because they are controlled independently. Click on Add Group. First, we will create the arm group. Give the name Panda_arm. Select the kinematic solver, and I am selecting KDL_kinematics. Then select the default planner algorithm, and here I am selecting RRT Connect. Click on Add Joints and select the arm joints, which are Panda_joint 1, 2, 3, 4, 5, 6, and 7. Click the forward arrow and then click Select. The arm group is now added with 7 revolute joints. Now we need to create the group for the gripper. Click on Add Group, give the name Panda_gripper. We do not need to select a kinematic solver here. Click on Add Joints and select the gripper joints, which are Panda_hand_joint, Panda_finger_joint 1 and 2. Click the forward arrow and then click Save. This will create the group for the gripper. Next, we need to define some default poses for the robot, which we can use later in MoveIt. Click on Robot Poses and then Add Pose. You can create any pose here. I am giving the name Panda_home. Using the sliders, you can rotate the joints and create a custom pose. I am keeping this as the home pose and clicking Save. Add another pose and give the name Panda_ready. Create another pose for the robot so that it looks like a ready pose. Make sure that you have selected the Panda_arm group while creating these poses, and then click Save. Now we will create poses for the gripper. Add a pose and give the name Panda_gripper_open. Select the Panda_gripper group. Move the gripper slightly forward and open it using the sliders, then click Save. Add another pose for the gripper close. Give the name Panda_gripper_close. Select the Panda_gripper group, and since it is already in the close position, just click Save. Now we have created 4 poses for the robot. Next is defining the end effector. Give the name of the end effector and select the gripper group. Then select the parent link where the arm and gripper are connected, which is Panda_link 8. Select the parent group as Panda_arm and click Save. Next is defining passive joints. We do not have any passive joints here, so we can skip this step. Next is ROS2 control URDF modification. Keep this as it is. Next is ROS2 controllers. Click on Auto Add. Here we need to edit the gripper controller. Select it, click Edit Selected, and change the controller type to position_controller/gripper_action_controller, then click Save. Next is MoveIt controllers. Click on Auto Add. Here also, we need to change the controller type for the gripper. Select it, click Edit Selected, and change the controller type to gripper_command, then click Save. Perception requires no changes. Launch files require no changes. In author information, write your name and any email address. Now go to Configuration Files. Click Browse and select the directory where you want to save this MoveIt package. I am selecting TET13 and creating a folder named Panda_MoveIt_config. Open it and click Open. Now click Generate Package. The package is successfully created. Close this window. Go to the folder where the package is created, and you can see the files added in this package. Now let's run this package and check it. Open the terminal in the same directory and source ROS2. Then build the package. After a successful build, source the package. Now launch the demo code for this package. The interface will open in RBIS2. Here you can see our robot is successfully loaded, and on the left-hand side, you can see the controls. Select the goal state as Panda_ready, which we created earlier, and click Plan and Execute. It says failed, so let's check the log. Here you can see the error. To solve this, close this window and press Ctrl+C. Under our created package, open the config folder and then open MoveIt_controllers.yaml. Here you can see that action_ns and default are missing for the ARM controller, which we need to add. The action_ns defines the action namespace, and default specifies the default controller. Add these 2 lines, save the file, and close it. Now build the package again and source it. Run the demo again. Select the goal state and click Plan and Execute. Now you can see the robot is moving to the ready pose. You can also move the robot using the interactive arrows by clicking and dragging the mouse. Click Plan and Execute again, and now it shows executed. Let's check the gripper. Change the planning group to Panda_gripper. Select the goal state Panda_gripper_open and click Plan and Execute. You can see the gripper opening. Now we are successfully able to control the robot with MoveIt. Next, we move to the Isaac Sim setup. Open Isaac Sim. Here I am using the workstation installed Isaac Sim. Now we need to create the environment. You can import your robot URDF and create your own environment, and I have already covered this topic in Tutorial 6. I will also show this later in this video. For now, I am directly using the existing example provided by NVIDIA for the Panda robot. Go to Window, then Examples, then Robotics Examples. Open Robotics Examples, expand ROS2, click on MoveIt, select Franka MoveIt, and load the sample scene. Stop the simulation. In this file, the action graph is already created, so we do not need to create our own. Open the graph and let's see it. There is a basic ROS2 context and simulation tick. Then we have a ROS2 subscriber block that subscribes to the topic Isaac_join_commands, which is published by MoveIt. It receives joint position and velocity commands and forwards them to the articulation controller. We need to select the target prim, which is the articulation root of the robot, and here it is already set to Franka. It also publishes updated joint states on the topic Isaac_join_states. Now we need to make some changes in our MoveIt package according to these topic names. Open our MoveIt package folder, go to the config folder, and open panda.ros2_control.zacro. Here we need to add 4 lines, which I will provide as a copy-paste patch in the description. Confirm that the topic names written here match the topic names used in Isaac Sim. Save this file and close it. Now open the terminal that we were using for MoveIt. Make sure you are in the MoveIt package directory, build the package again, and source it. Now run the demo code. Start the simulation in Isaac Sim. Now move the robot using MoveIt. Select the home pose and click Plan and Execute. You can see the panda arm moving in Isaac Sim exactly as it moves in MoveIt. Now select a random pose using the interactive arrows and click Plan and Execute. You can see the arm moving in Isaac Sim. Now check the gripper. Select the gripper group, choose the goal pose, and click Plan and Execute. You can see the gripper opening and closing. This is how you can control any robotic arm in Isaac Sim using MoveIt. You can also directly control it using a Python script by publishing joint command messages to the topic that Isaac Sim is subscribing to. Now let's save this file. Now I will quickly show you how to import the URDF, use your own environment, and create your own action graph. Create a new project and click Don't Save. I am using the same environment from Isaac Sim, which is the simple room. To import the file, go to the folder where the URDF file is located. Keep all the settings as they are and click Import. Click Yes, then Yes again. It will say that the URDF is already loaded in Isaac Sim because the Panda robot already exists in Isaac Sim Assets, so click No. Enable Isaac Sim Assets. Go to Robots. Wait for the assets to load and search for the Franka robot. Drag this robot into the stage panel under the world prim. Now to create the action graph. We do not need to create it from scratch because it is already available in the examples. Click on the Joint States action graph. A pop-up window will appear. Select the articulation root, which is Franka, enable both publisher and subscriber, and edit the topic names to Isaac_join_states and Isaac_join_commands. matching what we used in the MoveIt package. Click OK. You can see the graph added. Open it and verify that it is the same. Now open the MoveIt demo and run the simulation. You can see the robot moving to the same positions as commanded by MoveIt. Move it again to the home pose and check. It reaches the home pose. Check the grip or control as well. By following this procedure, you can control any robotic manipulator in Isaac Sim. If you encounter any errors during this process, let me know on my Discord channel, and I will definitely help you. If you find this video helpful, please like the video. It helps reach more people and gives me more motivation to create such content. Thanks for watching.